let's get settled in. Our next speaker is Zlatko Đurić with his talk about wildest streams. So welcome, Zlatko.
Hello. This thing works. So I have a question first. How many of you can take, like in a web page, a webcam feed? How many of you know how to do that? Okay, a few of you know. And can you like put it in a video tag on that page? And then maybe transform it into a canvas. And then maybe read that canvas into a heat map. And just, in 3 lines of code. Like, I don't think anybody can do that right now, but that's kind of what my talk is all about streams. So you can do that. First you stream, then you do stuff, and then you profit. So I'm going to talk about the second part. My name is Zlatko Đurić. I'm a Node.js primarily developer, so I do a lot of JavaScript on the server, and streams are all over the place. So this is why I kind of chose this topic to talk about. So here I am. Let's hear it. I have a few examples. Now I hope this works. I said a few times, but this is hardcore stuff. So I have a simple selfie stiller stream. So woo, there I am. It works. So basically, this is a web app where you can go and steal selfies. Like, I guess this is how the iCloud people lost their pictures a while ago. Anyway, so this is just a simple stream. So it's a webcam feed, and it goes right back into that page. So Alt tabby, not there. Okay, I might just there. Okay, so the next slide shows the same thing in case the internet is failing here. Okay, so how to do that? This is really pretty simple. You have a video tag on the page, and you have something called navigator.getUserMedia. It's still prefixed by like WebKit and Moz and stuff, but basically that's it. So navigator.getUserMedia, and you say I need a video or audio or something, and what you get back in a callback file method, it's a local media stream. So it's a stream of video data. So that's kind of how you can get a simple thing. It's really not good for stealing selfies because there's no code that will actually steal any selfie. So yeah, I'm cool, I can do that. But there's this guy on the internet called Andre George or something. He doesn't know how to do that. His camera is broken. His camera is basically, he doesn't know how to do video, he only knows how to do text. So that's kind of really cool, right? So I'm going back. Again, one helper slide. But we do have it. So he did that with like 3 lines of code. Right? Okay, so it's not really that simple. Again, he gets the user media. So he gets the webcam feed. Then there's some code, blah, 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 blah. Then the next thing, he has a small canvas thing, a whole small helper function that makes a canvas and takes that video tag into a canvas. It calls draw image. You can draw an image on a canvas from a video tag, so basically like capture frames. And what goes on next is a little bit more code, and you probably can't read it, but it's relatively simple. You go line by line, or every 2 lines or something, and then for each pixel, you character a little heat map, like how much red, how much blue, green, so you calculate some brightness, and blah, blah. And then you use that ASCII library, and you find which ASCII character code represents so much brightness on the screen. So that's how you get that cool feed. And then you just put that into a div or whatever. So let's up a level. So a heat map, I mean, This one is really amazing. Yeah, I can allow the access to the camera, and now I can do predator vision. Yeah! Woo! So this is really crazy stuff, but it boils down to the same principle. Again, take the video feed and then calculate differences between two frames to do all these red or whatever heat maps. Anyway, so this streaming stuff is great, right? It's poetry, it's pure art. So the guy also wrote a poem. It's called Longest Poem in the World. So, okay, Adobe, thank you. So this thing is 1.3 million lines long. So, yeah, you guys are all engineers, and 1.3 million lines of poetry is probably awful. But what he did there is he took a Twitter stream of tweets and then he made it rhyme. So basically he takes one tweet, then he finds another one that rhymes with the one before. I mean, it's so many conversions right there. So it's really a lot of crazy stuff that we can do with it. Again, in case the internet doesn't work, I have that slide. So that was a long introduction. I want to talk a little bit about streams, about all that cool stuff that's past now. Now it's a boring part. How we can use them, what other possibilities are there, and what's going on in like web standards part. So a bit more on that. Anyway, why a stream? So here on the left side you can see, or your right side, you can see that spider row, you know, that like Dropbox for paranoids. So if you want to download a video on your phone, you have to actually save the file. You have to download the whole file. And on the other side, it's regular, you know, video, YouTube or whatever. So what's the difference? This file is one whole chunk. It just, you know, starts downloading, downloads. When it breaks, you have to start all over again, and all that data is junk. You can't use it. But with this thing, you get data in chunks. You get one chunk, then another chunk, then another chunk. So you can work with that. And even if it breaks, you already have some usable data. And not just that, you can do pipes. So you can do pipeline. You can do that. Okay, get me that file. So now imagine doing all that heat map thing without streams. Download the file. Okay, wait, download. Okay, now go through that movie, calculate all those pixels and frames. Okay, now make another video. So okay, wait, and now you can show it on screen. So it's kind of, you have to process the whole thing. And with streams, you can just do chunks of data. And also another thing, though it sounds like poetry, it sounds like a nice organic thing. It's really not. It's really complex like they say, like traffic in Bombay. I mean, you have all those lanes, all those states, all those. Is this bit center now? Is this stream full of now? Is this buffer? So you have a lot of things to organize, to set up, a lot of things to take care of. So it's kind of not. It's not organic. You have to, it's very structured process. So where did this come from? I mean, to the web. Well, basically it came from the server, or even more from, you know, the LSD guys, Berkeley guys, like in the 70s. The Unix pipes, Unix stream. There are standard streams, 3 standard streams, like standard input, which is a keyboard mouse, standard output, which is a display, and standard error, which is almost always also a display. So basically, this is what they came up with. Because the disk was slow, the net was slow. So if you want to get some data and do something reasonable with it, you might as well just, you know, while you're waiting for the whole file, you can just start working on the part that you already have. So this is kind of where it came from. But what about the front end? I mean, we are doing something called webcam here. So until a few years ago, there was nothing native for this purpose. I mean, there is Flash, there are Java applets and stuff like the peer-to-peer, but none of that is native to web. So until a few years ago, you couldn't really do any streaming, let's say. On the servers, you could do some like Flash media servers, which is again Flash. You have to use plugins or peer-to-peer or various encoders that can do that, but nothing on the actual web. So the past, as far as web development is concerned, let's hope it stays the past. The present, so basically this says stability to unstable. It's taken from Node.js Streams API, and Node.js guys are far more along with streams than web browsers, but JavaScript and standards. And it's unstable. So at present, I mean, you can do amazing stuff with streams now, but some things are still not working just as well, and some things are still improving. So it's not really stable. We don't have a consistent API. So that brings us to the future. There is a Streams API draft at W3C. There's also another standards body called WG. I think they do a lot of those HTML5 boilerplates and evangeline, all that stuff. Anyway, so anyways, I was at a talk from this guy, Dominic Nicola, who is actually producing a lot of that standard. He works with Node.js guys, he knows the pain points, so he's trying to think of a reasonable way of how we can do this, all this cool streaming on the web without all that boilerplate code. So there's like on one side there's sources of streaming data, or we call it underlying source of data. So it's a webcam, it's a microphone, but if you think about it, geolocation, it's also like streaming data, or even set interval. When in JavaScript, set interval, it just kind of repeats, starts emitting some data. Or even Ajax, I mean, when you're reading something from the web, or WebSockets, File API, IndexedDB, all those things are kind of stream-like. But you can't do like WebSockets.get messages pipe to that canvas. No, we can't do that easily today. On the other side, there are sinks for that data, which is the canvas, which is a video tag or whatever, or we heard web components, so we can like use that as a sink, or again we can use another WebSocket or WebRTC or all those fancy new protocols. So what do the specs say? Well, they don't say it like this, it's legalese talk, it's complex talk, but basically there is something like this. You have a thing that is called a readable stream. And what that means is that stream you can read from it, you can get some data from it. So you should be able to say, okay, I want a new readable stream. And I'll just pass some options. I'll say, okay, give me the camera and maybe the audio or something, or whatever. And then you can also, on the other side, you can say, I want a writable stream, which is that canvas tag. So, and I just want to say, okay, just here are my options, here's my configuration. And there's a thing called a transform stream, which is basically something that combines a readable and a writable. So data comes in on one side, then you process it, turn it around, and then it goes changed on the other end. So those pipes, those things, those cool things, that's what's done in a transfer stream. So, like I said, the first example with a Predator or a camera or ASCII camera, we have a get user media, and we should be able to pipe that to canvas, and then pipe that to ASCII, and then not even show it on the screen. Maybe we can just pipe it to some sort of a transfer stream, and then pipe it on somebody else's screen. So this is what this piping thing means. But also there are a few things that are complex in that system. So we have a thing called pipe chains and backpressure. So what does that mean? What happens if you're, for example, if you are taking a stream and saving it to a disk? and you ran out of disk space. So it's an error, but your camera is still emitting your, I don't know, if you're on a mobile, your video is still streaming, your bandwidth is going to nothing. So there's a thing called backpressure. You should be able to say, okay, I can propagate errors all the way back. I can tell to my transport stream, to the guy ahead of me, I'm done, I'm dying, don't send me any more data. And then he'll send it to another upstream stream, and so on until that underlying source of data. But besides error propagation, there is also this backpressure propagation, which is basically what you say, I have a high water mark at 80%. I have a buffer of 10 frames, for example, and my high water mark is 8 frames. When I get to the 8 frames, tell all those uplink to stop sending data for a while, to pause, because I need to process all this and show it on screen. So that's called backpressure. So this is those two things, like transport streams and this backpressure is what enables great things like Ask Camera, which are fun, but it also enables some other things that we can use. So right now we have WebRTC and WebSockets, WebRTC and user media, which are already implemented as streams. But we also have WebSockets or web workers or Ajax or all those, everything basically in JavaScript API in the browser, like file system, audio, geolocation. So all those things can be treated as streams, and we should be able to tell, like in jQuery, like ajax.get video.mpg, and content type is a stream, so that I can just show it right away. So I don't have to download it first. So this is kind of what it proposes, and what we should be able to use in a few years. But we don't have to wait, because there are a lot of possibilities, a lot of existing apps. So like video and audio chat, which is based on WebRTC, something like Hangouts, but I don't know, open source, OpenTalk-RTC, take a look at that. Take a look at some other great video RTC apps. You can just go to a website and send somebody a link, and you have a video communication with them. No Skype, no plugins, nothing, just browsers. There's a thing called WebTorrent. So there's a torrent client in your browser. I actually have a Chromebook, so I can't run any torrent clients. But I could if I wanted, because right now there is a WebTorrent implemented with streaming. So there's also screen sharing apps, real-time analytics or user tracking, like when you're looking what your users are doing on the other side. So a lot of those things are already running there, and some of them are using this stream. So did I end up really soon? Anyway, I came here to this question time. So first question for me, like, is this thing cool or not? I guess. Okay, great. Anyway,
I have a question. So did you check any of the reactive libraries in JavaScript that do event streams and manipulate event streams? Because that's a similar approach, but you do plain event programming using streams. So reactive.js, bacon.js, stuff like that.
Yeah, so basically, yeah, the point is, yeah, right now you can do stuff like that. Some of these things are implemented as event series, but the point is, I want to be able to say, I want a readable stream, like new stream. Like you can say, I want a new file or a new URL. Yes?
What is the state? I know for PHP has Guzzle, which basically re-implements the Node.js, but what is the state of streams in other languages, basically statical file languages like .NET or JVM-based languages?
Oh, okay. Well, I don't know about .NET, but JVM, I mean, it's Java. They have various streams, libraries that are based on streams, and but I'm not sure if it's all kind of native or standard. I know in Node.js it's pretty standard. We have already streams version 2, which is broken. We are now waiting for version 3. But most of those things, especially compiled languages, they are older and they deal a lot with, they used to deal a lot more with handling all this video and, I don't know, streaming YouTube or Vimeo or whatever. All those things, they already stream data in a way. So basically, it's done. It's just not in the browser. Yeah.
Does streaming use a lot of memory?
Oh, that's one actually of the benefits. So basically, if you are downloading a file and you want to do that heat map, imagine if you just download the whole file. So basically, that's in 1 minute of video, it's 30 frames. So you have to download the whole 30 frames, hold it in memory. When you download it, then you do all those conversions, and then you show it on the screen. And if you are streaming all that, as soon as you get that first frame, you can just do the conversion and pass it on. And do the conversion and pass it. So basically, this is also kind of lowering the memory. I mean, if you use it smart, of course. I bet I could make anything crash.
Any other questions?
Especially I.
Okay, thank you, Zlatko.